In this video, you will learn how to write expressions as powers, how to find values of powers, and how to identify perfect squares. A power is a product of repeated factors. It's the answer to a multiplication problem where the factors are all the same number. So it's a product of repeated factors. The base of a power is the repeated factor. It's the number that is repeated over and over again. And the exponent of a power indicates the number of times the base is used as a factor. So the exponent tells how many times we repeat the base. Here's an example using the vocabulary. 3 to the fourth power. The 3 is the base. It's the number that is going to be repeated. It's the factor that will be repeated over and over. 4 is the exponent. The exponent is the number of times we will be repeating the multiplication of 3. And the entire piece, 3 to the power of 4, is called a power. 3 to the power of 4 looks like this. Remember, 3 is the factor that we will be repeating, and 4, or the exponent, is the number of times we will repeat the factor. So 3 to the fourth power means 3 times 3 times 3 times 3. You can see that the base 3 is repeated 4 times. We have a special way of saying some of the exponents, but others are pretty simple. 3 with an exponent of 2 can be said as 3 squared, or 3 to the second power. Then we have with an exponent of 3, 3 cubed, or 3 to the third power. Then we have 3 with an exponent of 4. This will just be said as 3 to the fourth power. And 3 with an exponent of 5 will just be said as 3 to the fifth power, and so on. Let's look at our first example. Write each product as a power. The problem here is 7 times 7 times 7 times 7 times 7. The number 7 is being repeated by multiplication 5 times. Remember, we need to write our base first. The base is the number that is being repeated over and over by multiplication, the factor. The base is 7. And then we need to write the exponent. The exponent is the number of times we repeat that multiplication, the number of times we see the number 7. We see it 5 times, so the exponent is 5. Our answer is 7 to the fifth power. Example number 2. Write each product as a power. 12 times 12 times 12. Remember, we need to first write the base. The base is the factor that is repeated multiple times. The base in this situation is 12. Then we need to write the exponent. The exponent is the number of times we repeat the multiplication of 12. Here there are 3 12s being multiplied. 12 times 12 times 12. So our exponent is 3. 12 to the third power, or 12 cubed. Example number 3. Write each product as a power. 100 times 100 times 100 times 100 times 100 times 100. That's 100 multiplied by itself 6 times. The base of 100 is being repeated 6 times. So the base is 100. And the exponent, because it's being repeated 6 times, the exponent is 6. So for this problem, the answer is 100 to the sixth power. Now it's your turn to try it. Pause the video and then try these 4 problems on your notes. Then start the video back up and see how you did. Are you ready for the answers? In number 1, the 2 is the base and it's being repeated 3 times. So we have 2 to the power of 3, or 2 to the third power, or 2 cubed. In number 2, the number 6 is the factor. It's the base, and it's being repeated 6 times, so we have 6 to the 6th power. In number 3, we have 15 as the factor or the base. It's being multiplied 4 times, so we have 15 to the 4th power. And number 4, we have 20 as a factor, being multiplied by itself 7 times, so we have 20 to the 7th power. Now let's try finding the values of powers. We will start with a power and then figure out how much it's worth. Example number 1, 7 squared, or 7 to the power of 2, or 7 to the 2nd power. 7 is the base, it's the factor that's being repeated. And 2 is the exponent, which tells us how many times we will repeat the 7. So 7 squared means 7 times 7. When we multiply that, we get 49. So the value of 7 squared is 49. Example number 2. Find the value of each power. 5 to the 3rd power, or 5 cubed. 5 is the base, so that's the number we will be multiplying several times. It will be repeated. And 3 is the number of times we will repeat it. So 5 cubed is the same as 5 times 5 times 5. When we multiply that, 5 times 5 is 25. And then multiply that by 5, and we get 125. So the value of 5 cubed is 125. Now it's your turn to try it. Pause the video and then try these 4 problems on your notes. Then start the video back up and see how you did. Are you ready to see the answers? Number 5, 6 cubed, is 6 times 6 times 6, which is equal to 216. Number 6, 9 squared, is 9 times 9, which is 81. Number 7, 3 to the 4th power, is 3 times 3 times 3 times 3, which is also 81. And number 8 is 18 squared, which is 18 times 18, and that equals 324. How did you do? The last thing we will do on this video is start identifying perfect squares. You should be able to start recognizing numbers that are perfect squares. A perfect square is the value of a number squared. So whatever the value is of 1 squared, or of 2 squared, or 3 squared, whatever the base might be, and then you square it, the value of that is called a perfect square. Let's look at this multiplication chart and see if we can find the perfect squares. If you multiply the same number times itself, that's squaring the number. So 1 times 1 is 1. So the number 1 is a perfect square, because if you square 1, its value is 1. The next perfect square is 4, because if you square 2, you get 4. 2 times 2 is 4. So 4 is a perfect square. We can continue on with 3 times 3, or 3 squared, which is 9. So 9 is a perfect square. 4 squared is 16. So 16 is a perfect square. 5 squared is 25. So 25 is a perfect square. The next perfect squares are 36, 49, 64, 81, 100. And then we start getting into some that might be a little less familiar, like 11 times 11, or 11 squared, which is 121. 12 squared, which is 144. So you can see on your multiplication chart, a diagonal line is created by all of the perfect squares: 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144. And it goes on forever, because any number can be squared, and whatever the result is a perfect square. Now you should know how to write expressions as powers, how to find values of powers, and how to identify perfect squares. Thanks for watching.